bigger room next time.
Blue sheets will tell them.
Yeah. Do it. Let's get it. All right. Hi, welcome to the MLS session at IETF 124. I gave the clicker slide thing, so yeah. Thanks. This is the brand new Notewell. You should please take a look. I'm supposed to linger for a minute so you can all read it, scan the QR code. But this is the IETF Notewell. It's a reminder about the processes and policies, including about conduct, privacy, and intellectual property rights. You agree to follow. You participate in the IETF, please read it carefully. You are encouraged to read the source documents to which the Notewells refers. Again, you can see that from the QR code. If you have any questions, feel free to talk to us, the chairs, or the area director, Paul, who's over in the corner. Or the on-site person. There's lots of people we can talk to. On-site tool. Please make sure to use this. A, make sure we get the correctly sized room. B, we use it to moderate the queue so people can get in and out. So in remote land, it's kind of fair for everybody. So please make sure you use that. Then we have our agenda, which mostly is talking about probably pretty quickly, actually, the 2 working group IDs that we have that are kind of actively being worked on. We do have another draft for Federation, which is kind of languishing, is kind of old. And then we have a bunch of non-working group IDs that we're going to talk about. We grouped the decentralized and distributed one together because of a request. So we thought that it would be good. I think Mark asked for 10 minutes and Conrad asked for 20. So I just kind of gave everybody 15. The idea is that we can go through both of those and then kind of get to questions. And then more, Rowan gets his own slide at the end. And then a bunch of IDs from Rowan. I don't know if anybody has anything to add. We don't have a lot of other time to move around here, but it depends on how people go fast and slow. We'll see if anybody has anything to add. Anything? Nope. All right, cool. Raphael, you're up. So stop this. Yeah. Stop sharing that thing. Cool, 1 second. I'm going to go to the bottom slide.
I only have 2 slides, but who knows?
I give this, I give that, I say yes.
Okay, I'm going to go really fast on these ones, given all the items we have on the agenda. So this is about MLS extensions.
Sorry, hold on.
Documents.
We need a scribe. Oh, sorry.
Tim.
Wow, that was fast. Thank you, Tim.
Sorry. Sorry.
All right. So the document is in the last call. So not much happened. 2 PRs have been merged. 73, that was about disambiguating a field in a struct. Application content is now called inner application content, the application framing struct. Thank you for that one, Rowan, I think. And component ID used to be 32 bits. It's now 16 bits. Thank you for the PR, Sean.
That's the one I can do.
And then we have 3 open issues and another PR that is linked to one of them. There was quite a bit of discussion. So in reverse chronologic order, number 74, something that got triggered by the amortized PQ MLS combiner, and that was brought over to MLS extension. There was quite a bit of discussion, and I think we are close to the end of that. Not sure if a PR is going to emerge from that. I think not. And 71 was, I think, Francisco's, who requested more guidance. Francisco's, in case you're in the call, please draft a PR for that so that we can close that. And then there was issue 70 and PR 72 from CSUN about cross-layer support. And I think there was an initial round of review from Conrad and one more open comment on that. And I think we should be able to close it after that. That's it for MLS extensions. Questions?
So from a chair's process perspective, right, we got a couple of open things that we need to address. We did it in the last call. We're pretty much done at this point, so we're addressing those, and then we're just going to wait anyways. So I guess there's no huge hurry, but I like to always try to be closing. When do you think we might be able to close these all out? By the new year?
well, hopefully in the next weeks.
Oh, that'd be even better. Cool.
I hope.
All right.
I
Yeah.
don't know. It's
Fair
not
enough.
entirely up to me, but let's
And
try and get there.
do you have any insight on implementation experience? Because that's what we were kind of waiting on.
Yeah, that is true. No, so nobody actually came forward. That's a good point. Thank you for mentioning it. Last time in Madrid, we said that we need better coverage from the implementations. So I have received no further input on that. So that's another call. If you're implementing any of that draft, please let me know.
All right.
Thank you.
Okay, Rohan, you are up. Or Richard, whoever's going to do this. Okay. You have control with the clicker. He's right there too. So.
Oh, there you are. Okay, so I took this table that I presented in Madrid and I updated it so that the names of the chems in the first 3 lines of this table match the corresponding chems in the HPKE PQ document. Richard and I are still having a disagreement over whether you should be allowed to have hyphens in the middle of your cipher suite names inside of the components.
What
Maybe
colors-
not the most important in terms of the color of the shed. We'll get there. But at this point, I'm going to put this up again, but we've used a minimum size of SHA-384 rather than SHA-256 because of some recommendations from NIST. If you feel strongly that for level 128, you would like SHA-256 instead of SHA-384, please speak up. Likewise, we're using AES 256 everywhere for a similar reason. If you'd like AES 128 or AES 192 instead, please speak up. And I believe I went back and kind of listened, and it sounded like there was strong support for the pure post-quantum cipher suites that have post-quantum signature algorithms at the end here, these two. That's what's currently in the draft. So if somebody really, really wants us to not do that, please say something. Otherwise, I'm gonna consider this issue closed. Mike.
Mike Ounsworth, that type column makes my brain hurt. Can you explain what that is doing?
Okay. So we have some. This is on the left side of the slash is the chem. On the right side is the signature algorithm. So this is a hybrid chem, traditional signature for the first 3. The next 2 are post-quantum chems, pure post-quantum chems, traditional cipher suites, or traditional signatures, and post-quantum.
So at the risk of being a bike shed color salesperson, PQ/T is all over the hybrid PQIP.
This does not appear.
Nomenclature is particularly colliding. with others.
This doesn't appear
That's it, I'm
anywhere in
done.
the draft. I just didn't have a lot of space on the slide. It's only the slide that uses that terminology. So anyway, specifically those 3 questions that I asked, does anybody feel uncomfortable with the direction that we're going with the contents of this table? Going,
Oh, there's cues.
okay. Britta,
Not uncomfortable, but I would say having a 1024 and 70 and 87 option with SHA 384 would be nice.
say that again.
So in other words, that last line, but with SHA 384 instead would be a nice
Instead
to
of
have.
512. Okay, so at 192 level with SHA 384, MLDSA 87, and MLChem 1024.
Yes.
Yes.
Okay, please raise it. Put an issue on on the GitHub.
I would amend that to say, like, let's not create multiple, let's just adapt that one.
Well, this one would no longer be 256, and then we would have two pure post-quantum cipher suites that are at level 192.
So Britta, let me ask that back to you. Do you want both SHA-384 and SHA-512 as options, or do you want one of them? Because as far as I'm concerned, like, Britta is basically the customer for these pure PQ ones.
I'd like to have them both as options. I definitely do want the 1024 bit as you currently have it, but I would like to have the 384 if possible as an option.
So you're saying MLChem 1024 with SHA-512 and MLChem 1024 with SHA-384.
Correct.
Let the combinatorics explode. Yeah.
Okay. Anybody else in the queue?
Yeah, I don't think I joined the queue, but I was just going to say from a process point of view, the HPKE docs, I'm going to submit those ASAP now. The HPKE chair is going to re-last call them and send them the ISG. So I think, assuming we get clearance from CFRG this week, so CFRG slides, forecast for anyone who's going to be there, say, like, we consider the bits to be fixed at this point. And so I think that's enough. I talked with the HPKE chairs. For the HPKE folks feel comfortable shipping their docs, I think we can probably do the same and go ahead and last call this once we get the right set of combinatorics to make everyone happy.
Yep, we need consensus on the CFRG list of this.
Yeah.
Okay. So going.
So what I hear is we're going to add a new line, and then we're going to wait a bit, and then we're going to last call it, unless somebody comes up with something earth-shattering.
That's my plan.
Okay. All right. I believe Conrad is up next. Do I see him here? Conrad. There he is. Do you want to present, Conrad, or do you want me to present and you can just say next?
Feel free to present. Hi, everyone. It's just like 3 slides or something.
Yep, let me do it. I think I got the right one here. Oh, no. Did I not upload one? Yeah, this is yours. Okay.
Okay. Yeah, maybe as a quick opener to this section, because this is a bit confusing, admittedly. There are 2 drafts. It's decentralized MLS, which I'm going to talk about, and then there's distributed MLS, which both abbreviate to DMLS, and both kind of roughly try to solve a problem in the space of decentralized applications generally. And we've had a very nice discussion with essentially the joint team of authors of both drafts, and to figure out, where are the differences, where do we line up? And it turns out like we have somewhat different threat models, and we're trying to solve different problems within this space. And maybe Mark will, or Britta will, I'm not sure who's presenting. I think Mark is going to say a few words on this too. But yeah, so as far as we're concerned, like these are 2 kind of complementary approaches that try to solve different subsets of this decentralized MLS problem. Okay, so yeah, quick recap. What is this? I think I've talked about this at the last IETF as well. So this is essentially an implementation of the Fork Resilient Continuous Group Key Agreement paper by Joao Alwin, Marta Moacek, and Yanis Telekounis. Great work, and this essentially significantly improves forward secrecy in MLS if you allow for essentially forks. So in standard MLS, we have the delivery service, and in most architectures, that means epochs are kind of chained in a linear chain where you have one commit between the two different epochs. But if you have a situation which is a bit more decentralized, where you can have commits out of order, or we have conflicting commits, then you can end up not with a chain, but with a DAG, essentially, so a tree of states where you have one epoch and then 2 commits come in at the same time, and then you get a branch off point, and you have a forked group state, essentially. And that's generally not great for forward secrecy because you need to keep around old group states if you want to process these out of order commits. And this paper by Joel, Marta, and Yanis kind of has a nice trick of using puncturable pseudorandom function to get a nicer forward secrecy in these cases. Other than that, it's relatively vanilla MLS, but the PPRF comes with some storage overhead. Next slide, please. So yeah, as I said, like our use case is mostly in scenarios where you have large groups. So we get most of MLS's efficiency in those cases, log n and all that, and an environment where there's not that much fork probability, because if you end up with a lot of like forked group states, especially in the post-quantum case, group states get to be quite big, and then ideally you have an environment where you have an idea of when there might be a fork or when it might not. So for example, if you have a federated environment and your worry is with net splits between the individual servers, and behind the servers you have all the clients, then the servers can detect the forks and instruct the clients, hey, now keep this particular group state around because there might be commits from the other side coming in at some point when we rejoin the network. And I think, is there another slide? Sorry, I can't remember. Yeah, so changelog, essentially, since last time we simplified the draft somewhat. We had some nice discussions in the meantime. There are a few improvements coming in on less storage overhead, and inspired also by the distributed MLS draft. We might also consider what they're doing, which is reusing key packages, reusing leaf nodes from individual fork states to improve forward secrecy, or PCS even more, or PCSFS, that middle thing between the two. And and then ideally we would like to move towards adoption when we've done that. We've had some strong interest from, for example, the Matrix folks on looking at this. And since we're essentially just implementing a proposal by academia, I want to say, we have the advantage of having a security proof already existing, although of course we're going to make improvements. So parts of these might have to be redone, but generally the general approach is relatively stable at this point. Any questions?
Okay, I see a thumbs up from
Thumbs
Richard.
up. Thanks, Richard.
I'll go to the next set of slides, and then we can, since you're here, assuming I got them in distributed, I'll do this, and then I'm going to give you the clicker, and you can be in charge of the slides. Yes. Great. You're welcome.
All right, so to continue this, we're working in a similar problem space. We came about it from a different perspective. So trying to solve for the branching out from a more complex use case, from having consistent commit order give us our shared cryptographic state in MLS. We started from, rather than lazily considering, well, when forks commit, how to resolve them, we started off with considering all local state. So in a situation where you're deploying with less of a federated case than considering every party is a local actor, you have local state. Those actors will mutate their state linearly in time for forward secrecy and post-compromise security. They're going to tell each other about updates. And the goal is, how do you get the set of local actors to act in a coordinated way so that they have shared expectations around how the collective state mutates, and to incorporate state from other parties as you hear about them, so that collectively you can get the properties that we would like of evolving cryptographic state through these PCS updates. And so the result is your local state is an MLS group. Each participant of the D group creates an MLS group to distribute their state and to encrypt messages. Only the creator of the same group can send messages, proposals, or commits. And so we first introduced this in IETF 122. Since then, from feedback, we've incorporated feedback around the security properties. So the core incorporation mechanism is if Alice wants to introduce new key material to heal her own send group, she's going to commit a new leaf node for herself. She's going to distribute that commit. And Bob, as when he has received Alice's DMLS update, is going to incorporate that update in two ways. He's going to introduce a dependency in his group on the new epoch that Alice has just generated by exporting and importing a PSK. And he's also going to copy over that newly committed leaf node to replace Alice's current representation in Bob's group. And so this is the mechanism that we're going to accomplish PCS across the send groups as users update their own. So our status, there's two parties that are have preliminary implementations, are implementing this as we adjust this. We've incorporated reviewer feedback since the last time we've presented this, and we believe this is ready for working group adoption. Some things that other folks have raised that we're interested in incorporating, add, remove, and reinit, bringing in some more capabilities from vanilla MLS into this group context. So with that, I will open it up for questions. For either of us.
Brendan? Oh, there he is.
Hello. So one question I had was that I was wondering if you could talk more. Well, so you have a consensus protocol here that you're using to get all of the users to agree on a group membership. So you already have a consensus protocol that you have to do. So why don't you use that same consensus protocol just to agree on which commit comes one after the other, right?
The initial version of this had static groups. So considering the application was responsible for defining group membership, and downstream of the application's definition of group membership, this is a primitive for within a fixed set of members where the members, if the individual members evolve, but the group membership as a whole is not. So in that light, I think we are thinking of, is there a mechanism of adding or removing that does not require consensus? That's interesting. That's something that we're kind of working around. But the genesis and the existing implementations punt that as a application choice of which this is downstream.
Yeah, I mean, when you have any of these non-centralized, centrally coordinated modes, either this DMLS or the other DMLS, like there's always a question of what the right resolution is for who should be in a group when the decentralized components come back together. Matrix, for example, has a whole algorithm, a very complex algorithm with funny corner cases devoted to that resolution. But that's not why I got up. So I think this is a worthwhile contribution, even with static groups, and I think that there's plenty of solutions for solving for dynamic membership, which, as you say, will ultimately end up punting the application at some level. Reason I got up is to say I'm slightly sad we have two docs here. Like we have one problem. I don't have a DS, or I don't have a centralized thing that I can rely on to do coordination. We have multiple approaches because there's multiple constraint sets. But if I'm an implementer, I've got the problem, and I'm going to have to like look across this set of things and figure out which works for me. So like I would be slightly happier if we adopted a single merge document here that was like, so you don't have a centralized DS. Here are some trade-offs you might have, and here are some approaches that are available that you could use to solve in various cases. So I would slightly prefer to adopt one rather than two document, because I think it would provide a more consolidated view on the problem. But I guess we could do it too if we need to. No. So Rowan said we could have battle royale between these two, but I actually don't think that's the pessimal answer, because there are legitimately different cases here.
Britta?
Yeah, just to address that, I was mostly in line to comment on or respond to Brendan's question, but I think it's worth noting there that these are actually two different problem cases. And I mean, we have similar acronym at the moment, which is a bit funny that we all stumbled. Apparently DMLS is a popular ordering of letters, but these are really two different use cases. So the fact of talking about decentralization is looking a lot at that federated case, where you can have slight disruptions or reordering of commits, and so it's very nice to be able to resolve those. Whereas in the distributed MLS version, it is a lot more on, for example, a mesh network or things that really get very disconnected and out of order. And instead of fighting that or taking on that constant fight, you essentially are dealing with this by having each member being in control of the ordering of commits within their own SYN group. Now, that comes at some overhead costs, so you wouldn't want to use it generically in the federated sense because you really want to have lower overhead if you can. So we've got two different uses and two different problem sets, really.
All right, so I think we're at the point where we're trying to elicit feedback from other people in the group, how they feel about this. Richard's kind of leaning towards one. I guess I'm curious what other people think. I don't know, Nick, do you have any thoughts?
I mean, in the simplest terms, how would you compare and contrast the constraints that drive this versus the other one? I think that having that answer would help simplify our path.
That for me, that question is downstream. I think the conversation we've been having on the mailing list and thinking about it as an implementer, how much knowledge of the fork state does the application have to consider, and then have a strategy? And then you have to do the state tracking, and then you have to have a strategy. So I think there is the way that the implementation has introduced a state bleeds into the application. I would say from ours, it's defined. There are, I'll speak for my implementation, much more fixed expectations for the application. It will tell the application these commits are missing and you need to go find a way to get them. Whether how you do so is your problem, but we have a defined state, right? The structure of this is predefined, whereas you're lazily discovering the state of forks as you evolve them. And so I think that they're crossing up and down that boundary in different directions.
Rhoda?
I'll weigh in with some perspective there for the constraints. The distributed sense is really where you're talking about a decentralized, not decentralized, I shouldn't use that word, it's a disconnected graph, if you will, in your topology. You can have like mesh networks, you can have it very distributed. In a decentralized case, you're looking a lot more federated, where it's not necessarily centralized and you can get things out of order. Now, when you get a very, very distributed case, then dealing with forks and trying to resolve forks becomes very problematic. And so what the Mark's draft is doing is saying, if you have all internally honest parties, you actually can't fork at all. For internally honest parties, you're not going to, each person has control of the ordering of their commits. So you'll order those in different ways in different groups, but you're not going to fork, which avoids that issue. Now, in the decentralized case, in Conrad's draft, you have a really nice way of resolving forks if they've occurred, and you've got some marginal forking, which could happen if you're talking about a federated environment. And so that's a nice way of resolving it and being able to have all the big scaling you might expect in a federated environment, because that does have the logarithmic scaling. And the distributed one does not have the logarithmic scaling. So you're talking about two different types of use constraints there. And I think accounting for that is important, because we actually can't merge these two drafts. One avoids forks altogether, and the other one resolves forks. So merging it doesn't really make sense. Whereas you got two different uses, and it might be worth talking, having all those in the room who have either a decentralized or a distributed use case, see what they would use, and probably those use cases should drive these designs a little bit.
Yeah, Rafa Robert. Yeah, I think, Britta, you just said most of what I was going to say, but maybe I can try and repeat it in slightly different words regarding the decentralized MLS draft from Conrad. I think the idea there is that, so it's not exactly what Richard said, there is no DS. It's more like you don't know if there is a DS, but there could be a natural DS, which is essentially time. So you don't have collisions on commits if you don't have a net split and if there is sufficient time between the commits. So essentially with the decentralized MLS draft, you fall back to absolutely normal MLS, meaning you have the logarithmic efficiency for commits. You have all the other advantages and disadvantages of MLS, except that, you know, whenever there is a collision, because there is no DS in the form of a central server or, you know, any other shape, then you don't lose the disadvantage of not having imperfect forward secrecy. Yeah, whereas the distributed MLS draft is obviously not as efficient, but starts from the premise that yeah, the network topology is really much more complicated, and there's no good chance of having a natural delivery service occurring somehow. And both are valid use cases, obviously.
Richard?
Yeah, I guess I still kind of come at this from the dumb implementer point of view. Like as Raphael said, like when I'm gonna try and figure out how to add MLS to my system, like I've got a system that exists that can send messages around, and it has certain properties. And like I'm gonna need a guide to see which of these mechanisms fits well with my set of constraints. So like either we write extended introductions on both of these so that I can look at each one individually, or we write an introduction section in a consolidated draft and have both of these subsections. So like, I think that's the thing that needs to get written down is like, what are the trade-offs and how do I, as an implementer coming to this with a set of constraints, decide which one of these matches best?
Would it make sense to adopt like 3 documents? One is, here's how you choose between using document A or B. Because we're hearing that it's going to be very difficult to merge these two.
To be clear, I was not proposing they merge at any technical level.
No, I mean, even textually.
I mean, copy paste works, bro. Like, Markdown's not that complicated. But we can figure it out.
Raising my hand.
So 2 cents on that. Although I hesitate to back a proposal for 3 documents, it probably makes sense in some way for the working group to have an informational document on using MLS and distributed settings, including the main protocol itself and considerations therein.
Architecture document.
Don't look at me. I ain't writing that shit. But I was just going to say, like, by the time you're writing an architecture document and trying to align on terminology, like, which you should also do if you're writing an architecture document, well, like, if you're aligning on terminology, that makes the 2 things read more better together. So you like the copy paste works even better.
Does the merge align the timelines for the 2?
I don't know that there's a timeline for any of this, unfortunately. That's the catch. Yeah. All right, so I think we're going to have to get our heads together as chairs and talk to the authors to figure out what is our way forward. I'm hearing there's a number of ways forward. Some are more attractive than others, but there is a way forward, and that's what we want to do if people are interested in getting things together. So thanks for your time. We're probably going to get done a little early, but that's okay. All right, we'll take the clicker back. Who is next? I believe it's Conrad. load up. We're doing leaf operation intents, right?
Yeah, I think so.
Okay, confirm my selection. Don't leave the room. All right, cool.
Okay.
Just, again, say next and I'll go to the next one.
Yeah, so the next two drafts are going to be less controversial, I think, or at least like smaller and simpler. Leaf operation intents, I talked about this last IETF. This is about specifically leaving a group, and we have different kind of different scenarios in which leaving a group in MLS is tricky. Next slide, please. And one is, so Rowan has already kind of proposed a couple of solutions, starting with a self-remove proposal, which allows you to remove yourself even if the next commit that comes into the group is an external commit. And then I think there's currently a draft that allows a similar thing for regular remove proposals. And the leave operation intent is specifically for a different use case where the client is offline but wants to cleanly leave a group. And in any approach that we have right now, the client needs to have the current group state. So even if you have a centralized DS, like if you want to leave the group, you need to be online because whatever you do, whatever kind of proposal, if you want to do a proposal, you have to have the current group state. And so if you're offline and the client, interacts with, the user interacts with a device and says, I want to leave this group, then currently you can either just delete the group and then somehow time out of the group at some point, or you have to wait until you're back online, which I think is not great if you're in a position where you want to just, get the group state away, like out of your device or remove it from your device, but then do so cleanly. And so this is what this does. This essentially kind of disconnects. Intents are essentially very similar to proposals, except that they're not connected to the group state. So you don't need to have the up-to-date group state, but instead they're connected to the leave of the affected of the sender, essentially. So if you have an intent that essentially just says, I want to leave this group, that's valid until your leave changes. So until you do an update. So that limits the amount of replay, possibility for replay attacks that you have. And that's pretty much it. Since the last IETF, I've gotten some feedback. And yeah, thank you for changing the slide there. I've gotten some feedback that people wanted this also to be able to remove associated clients. As a quick explanation, if you have MLS and you want for example, your users to have multiple devices, then one of the options to do that is to have each device be its own leaf. And so if I have an intent that removes only my leaf, then that doesn't allow the whole user to leave the group. And so right now I just added a flag to the intent in the most recent draft version that says, hey, please also remove all the other associated clients that are in this group. And then which clients are associated is up to the authentication service. MLS doesn't really care about these things, so we punt that essentially to the application. And that's pretty much it. Again, I got some interest from the working group. I have simplified the draft. I've thrown out the option to also do an update. It's not extensible anymore. So I'm now wondering, is there any interest? Should we move on towards an adoption? Or yeah, I'd be interested to hear what the working group thinks. Are there any questions?
All right, well, let's start off with questions first, but I'm going to start off with the first question. Who's read this draft? All right, I got two people that raised their hand, Conrad, and they're the usual suspects. So I think it's probably premature to do any kind of adoption, but if there are questions, feel free to jump up there. And Rowan, you're first.
Okay, yeah, I mean, this is really just more of like a little bit of spin, I guess, but I think the motivation needs to be a little clearer in that why somebody would, particularly if we have this associated members option, why someone why it would be a better user experience for somebody to say, okay, I'm offline, but I want to leave now. And then at some point in the indeterminate future, I'm going to send this message, and all the other clients are going to just suddenly see the intent as well and be like, oh, I'm supposed to delete myself, or I'm supposed to be deleted. I think we need to like have a little bit more of a view of the use case of like how the other clients in the system are all going to react to this intent. And the alternative is, that you have to wait until you have to come up and you have to go get the current group state to go send the message, but you at least need to be online to send the message to send an intent. So yeah, anyway.
Okay.
Just strong.
Thanks for the feedback. Yeah, good question. I guess in the scenario that I was envisioning with you have a user and you have multiple devices, then those other devices will not be surprised because the user would be the one initiating the operation. But sure, I'll go back to the draft and make this a bit clearer, and then I'll wait for feedback and see if there's more interest.
So this has worked in the past. Is there anyone else willing to volunteer to read this draft? It's short.
It is a short draft.
Okay, we'll try to twist some arms.
Okay, that's all right. Then we can move on to virtual clients, I think.
So virtual clients is up next. All right.
Okay. This is a bit of a bigger one, as I just sketched. So if you want to have multiple clients that are associated with the same entity, and the most common example is you have a user that has multiple devices, then kind of the easiest option is to just have each of these devices be its own leaf in an MLS group. But if you want to, for example, hide your metadata a little bit and say, I don't want people to know if I'm sending a message from my phone or from my work computer, then you can have something like virtual clients. And I should note, all right, just brief sketch of the functionality. This is essentially like if you imagine the MLS tree as a big old tree, then now with virtual clients, you can have beneath each leaf, you can essentially have its own kind of small MLS group. Except that this MLS group can then, this kind of subgroup can then power a client, like multiple clients in multiple different MLS group. And so, and this gives you, and we have to kind of suss that out a little bit, but this should give you some efficiency benefits, because as a result, if everyone uses these kind of small subgroups, then the actual kind of supergroups will become smaller, because not everyone's devices are going to hang out in all of those big groups. Next slide, please. And so in the past, we've had, one of the difficulties you run into if you have multiple kind of individual clients act as like a single client in an MLS group, then if you want to send an application message and they send an application message at the same time, they're going to use the same key and the same nonce. And nonce reuse is considered bad, not just considered, it's actually catastrophic for confidentiality. So avoiding that has been a challenge. And in the past, we've had two different approaches to this. One by using a PPRF, and then you would puncture at a random place for each message, but that has proved to be unworkable because PPRFs can grow quite big if the inputs are big. And that's just not viable for something like application messages, where you would do something like a lot within an individual epoch and then keep the state around. And so we've actually, like that was the one that I was in favor of, but we've since then, I and my co-authors have changed our opinion and consider the solution of the other draft to be more workable, which was by Brandon. And that was to avoid the nonce reuse by using the reuse guard, which is kind of what it's for, although the reuse guard is mostly meant to be kind of a last ditch effort in case you had a loss of state and you would accidentally send out a message encrypted with the same nonce. And then key reuse we would prevent at the level of the DS without going too much into detail here. And so we've we've gotten together, the authors of both kind of quote unquote competing drafts, and we've agreed to join forces and work on a single document. And that document is in the works. There are a few things we want to still change there, and then ideally also we'd like to move towards adoption. We've had, oh, sorry, next slide, please, I think. Next slide, please. Sorry, I kind of talked over this one.
That's it.
Oh, that's it. I'm sorry. Then I'm missing a slide, but anyway, what I was going to say, yeah. So we're going to merge the two documents, implement a few of the changes we had in mind, and then ideally also move towards a call for adoption. We've had interest from the MIMI working group, for example, in looking at something like virtual clients to actually implement this one user with multiple devices scenario. So yeah, that's the plan. I don't know if any, well, Brandon is here. Brandon, if I forgot anything, feel free to.
I see a thumbs up from Brendan, so.
Great, thank you. Anyone else? Any questions?
Questions? All right, Raphael.
Yeah, quick question. Just wondering if anyone is particularly opposed to that. Otherwise, I would say we should go full steam ahead.
I mean, we've been talking about this for a while, right? And it seems like we're basically at the point where if people have read this and comfortable with it, we're getting very near an adoption call, right? So who's read this draft? I got more hands. Look at that. I got 5. That's a good number. Unless Sophie was just playing with her hair. But I think we're definitely there. So let's, 4. So I think that's actually for us is a pretty good number. So I'll talk with Nick afterwards and we can see about getting this started. I will go back. Conrad reminded me that we skipped over the single signature key packages draft. So we'll kind of jump back. I skipped it back.
Yeah. Okay. I was kind of expecting a second small draft after the leaf note intent string. Okay, so earlier we were talking about, or Rowan was talking about kind of PQ Cypher suites, and we've implemented the amortized, what's the new name? Amortized MLS PQ combiner draft, and in that course we've also used the fancy new PQ signatures. And well, what can I say? Signatures are big now if you do that. And so we took a look at MLS and tried to figure out where we can shave off a signature or two. And one of these places was the key package. As a kind of small reminder, a key package is essentially a wrapper around the leaf node that ends up in the MLS tree. And the wrapper consists of a few bits of data, and then it's the leaf node inside. And right now we have a signature both kind of over the whole wrapper as part of the outside, and then the leaf node itself is also signed because this is what ends up in the MLS group. And the idea was to just leave out the signature on the outside and then instead compute a hash over just the shell and put that inside of the leaf node as a hash. And so the signature of the leaf node would then also kind of through this hash cover the outer wrapping, and we would save a signature. Although this is a new wire format, of course. Rowan.
Yeah, so why don't we just make it an extension, and then you just have, you just don't, you have the extra, the extension contains the hash from the leaf node inside of, the leaf node extension contains the hash of the stuff in the key package that you want. And the existence of the extension or a different extension in your, in your group context says that you're using this, and therefore there will not be a signature and the format is different. I don't think we need a wire format for this.
But it's a key package, so it's not connected to any group where you have a group context that tells you what's accepted and what's not. It's just like a
But the
change.
key package has key package extensions in it as well.
Sure. I mean, the parsing would parse it differently because the signature field would just be missing, I guess.
It would be zero, have a zero length. It's a vec, right?
Sure. Okay. I mean, I'm not wed to having a new wire format. So if we can get away without having one, I think we thought this through and decided that we needed a new wire format, but I might be wrong on this. Like, sure, I'll take another look, and if we can avoid the wire format, I'm all for it.
You'll see the method to my concern later.
Okay. Next slide, please. Is there another slide? I think.
Yes.
Okay, because we found another place where we could potentially save a signature, and that's a bit more. That'd be kind of a bit more. You would gain even more or lose even more, and that's commits. However, commits are more complex because you have all the fancy framing structure that we have in MLS that kind of gets in the way a bit. So we haven't done the actual legwork and written this down in terms of the structs involved and everything. But before we've gone ahead with this, we wanted to know if there's general interest in the working group, because I mean, commits we expect to be sent quite often, and so saving another signature there, even in the normal case, might be nice at the cost of some complexity in terms of, you know, parsing and stuff. Whether we get that into its own wire format, I don't know. To be determined. Is there generally interest in saving signatures?
I see some heads nodding.
I'm going to go out on a limb here and say that probably as we go towards post-quantum, that there'll be more interest in saving signatures as a random guess. Would you mind clarifying a little bit on how you go about saving it for the commit case? Just intuition-wise.
Right. It's essentially like it's essentially the same as for the key package. So we're taking the outer shell, hashing just the outer shell, and putting a hash where it's covered by the hash in the by the hash over the leaf node in the update path. But again, like capturing this outer shell in case of the commit is a bit harder, and we weren't like, I'm kind of 95% sure we can do it because there's also the confirmation tag and the membership hash and that kind of stuff. But I think that's outside of the signature. Yeah, again, we'd have to take another look. Raphael, feel free to correct me if I'm wrong here.
Yeah, just adding to that quickly. Yeah, so the intuition is indeed that, I mean, when you have an update, essentially, as a commit, you sign the commit, which would be the outer shell, and then you sign the new leaf node, which becomes the update to your leaf. And so essentially you have two signatures that sign almost the same thing. And we are 99% sure that it works out by getting rid of the outer one, because obviously long-term you want to keep the leaf node. The commit you throw away after it's been applied. So that's the one you want to get rid of. As Conrad said, it was not entirely clear, so that's a 1% of uncertainty that's remaining, simply because of the order of things. It might be that there is some sort of circle dependency. But so the practical concern why this has not been fully fleshed out is that I think we would have to redo a lot of the framing that we have in MLS just to have a full specification. Even if it's somewhat trivial in the end, we have to redo all this layering, these onion layers we have in MLS. So hence the question, is this of interest or not? Because we didn't want to do the work if people don't think this is a good idea.
Yeah, so my typical questions like, who has read this draft? Yeah, we got a couple of the usual suspects said they did. So I think we have to take some more discussion to the list about this before taking to progress it. Okay.
Okay, but I'm taking away like general interest in shaving off signatures, so we might just go ahead and try to figure out how expensive shaving off the signature in the commit is.
Okay.
Thank you.
All right. Rowan, you are up. Where's Rowan's drafts? There we go. Confirm my selection. Get to the bot. You are in charge of the clicker now.
All right. Hello, hello. I've got a lot of drafts here. I'm not going to spend a lot of time on each one. I've already talked about the web token credentials drafts, but there's a draft here where I just showed a structure in which we can represent selected disclosure JSON web tokens and selective disclosure CBOR web tokens. The thing about these is that you don't really need to do any actual selective disclosure to use these. You can take a regular JOT and stick it in the place where the SD JOT goes, and it would work just fine. And in a COT, if you have a COT, the main requirement that you would need if you wanted to stick it inside of an SD COT is that you would need a confirmation key. So key binding in SD COT is required. So yeah, like there are a lot of things you could do with this. And instead of having this gobbledygook here in base 64, you could have some nice binary instead that was, split out into the component pieces and not have a bunch of base 64 like bloating up your leaf node. But other than that, yeah, like if you have some existing JOTs that you want to be able to use, you could go and use them in MLS this way. Has anybody read this? I think Richard read it. Yeah. Okay. There is also the ability to do encrypted disclosures in SD-COT, and this is there are basically two use cases for this. One is RATs, and the other is MLS. So it means you could encrypt something with a key that could be only known to the members or a subset of the members. And so they could read those disclosures. So like the DS would not be able to see something that is in a credential, but the members or subset of members, like the moderators, would be able to see it. And we've talked about several places where this would be a nice property to have. So I think, if you have thought that that would be nice to have, here's one way we could address that. All right. Something a little bit more of mainstream concern, perhaps, for folks. So we've got these two models of DSs. We have the DSs that need a public message handshake or semi-private message handshake, and we have the private message handshake ones. And one of the things that people usually do when they support public message and they have a DS that sees your group context and sees your commits and sees your ratchet trees is that they can be helpful and provide you with a group info. So some new member can go and join a group using an external commit. Well, this isn't so nice. What happens when somebody externally commits and you happen to have a bunch of remove proposals lying around? And we've discussed this with the self-remove proposal, but this only really solves this for your own leaf node. But if you have multiple members of the group that are all sort of associated with the same user, then you really want to be able to sort of send a bundle of stuff in the Mimi case, for example, of one remove for your own member, remove proposals for the other clients associated with your user, and an app data update, removing yourself from the participant list. Wouldn't it be nice if instead of making special exceptions on a per proposal basis, that we just said, look, if you're going to do external commits from your DS, you already are like making the DS hang on to this group info. why don't you have it also hang on to your proposals as well? And you just send the proposals with the group info and they get committed all together. I think that would be much simpler. Yeah. I've been raising this idea for a long time. This is now almost 2 years that I've been mentioning this. I think that we're coming up with increasingly more complicated workarounds for this problem, and I think we just need to go do this instead of other more complicated things. And yes, there is just like with the self-remove proposal, the client can't independently validate a signature or something like that. But we have other solutions to this problem, and we also have we're sort of in the same boat with splitting your group. The kinds of things that somebody could do and malicious party could do to try to split your group. We need to solve those things, and we could solve all of them all at once instead of being afraid of this problem.
So very quick clarification. So in the MLS protocol draft, we currently exclude that we allow anything in an external commit unless it's a remove proposal for the own leave, correct?
Sorry, the self-remove proposal is a single empty struct. And so it says,
I mean in the MLS protocol draft.
In the MLS.
So that I'm just trying to clarify what the
in RFC 9420.
Yes. Sorry, not draft. Yes, it's an RFC.
Yeah.
It's going to take me another 5 years to mentally get there.
So it says that when an external commit is processed, that otherwise valid pending proposals are ignored. And then it goes on to say later that new proposal types could basically say that they can be included in external commits.
Yeah, exactly. So that's exactly where I was going to get at. So the problem you're describing here is the existing ones. You would like to make those legal, quote unquote, as well in a regular external commit. So we're talking about add proposals, remove proposals, and update proposals.
I mean,
PSK proposals.
I would be
and reinit, because all others can already specify that.
Yeah. So, for example, maybe we don't want to do group like a GC proposal, but having the ability to do certainly removes and maybe updates, maybe adds, right? External commits it doesn't really make sense for you to include adds for other people in an external commit because they won't, that's weird. But
sorry, why is it weird to add other people in external commit?
Yeah, I mean, okay, I suppose maybe it isn't so weird, but it's certainly it's not traditional. There are other ways that you can add somebody besides, externally committing and at the same time adding your friends. But fair enough.
But yeah, I mean, that's exactly the point. We made some assumptions back then on what's traditional and what's not, and that has apparently changed since. So why not open it up to any proposal?
So I didn't actually try to, specify which ones you would or wouldn't allow, but that generically that we would allow this kind of behavior, and then we can go through and tick off the list and decide if there's something that we want to, if that's really actually harmful that we want to remove.
Okay. But so just to understand, what you're proposing is an extension. Is that correct?
Correct.
Okay. Thanks.
Okay. And there's more.
Before moving on to new things, a question on that last one.
Yeah. Go for it.
Does this design change anything about the traceability from the AS side and adding additional keys per group versus what we had before in MLS where the AS might not need to know which members are in which groups?
The AS shouldn't have to know anything different than it does already. So this is purely a DS matter. It's whether, the DS, if the DS is already doing external commits, it already knows it, and providing group infos, it already has your ratchet tree and all your commits. And so it knowing that somebody submitted these pending proposals and just forwarding them along with the group info doesn't reveal any new information to the DS, and the AS is oblivious.
Okay, thank you.
Okay. All right. Okay, so I talked about earlier about the how we have the sort of two camps. We have the DSs that have that use public message handshakes and the DSs that do private message handshakes. So this is a solution for a little hole that we have for the private message handshake DS folks. So when we have a private message group and somebody wants to send an external proposal, they now all of a sudden have weaker protection for privacy than they did if they were added by a member of the group. So if I send an external proposal, that's got to be a public message, and so the contents are visible to the DS. Whereas if I was added by an existing member, that would not I would not have my leaf node visible to the DS. Mushtaba, are you there? Would you like to present the next couple of slides?
Yeah, I'd love to. Do you hear
All
me?
right. Yep, I'm going to advance to the next slide. Did you tell me when to go next?
Yeah, perfect. Thank you. So as Ron mentioned, the problem is we have a DS. We don't want to tell the DS what's going on, or the DS knows what we are doing, especially about the external messages. So we're defining a new wire format to have a private external message that the new joiners will use the HPK encrypt that we put in a new data shared before, like on the DS. So everyone will get those information to basically shape the external commit, but at the end they will encrypt it via those information. And they will send the external add proposal, but it will be encrypted by all the information already shared on the DS. Could you please go to the next slide? Thank you. So here the information that I've said that they will share on the DS, the external encryption info. So it's from the future epoch, because they need to calculate it for the future epoch, because when the new joiners will use these encryption info to encrypt the public message they have, so they will make it a private message. So within that, the join, the external join one, they will because everyone needs to decrypt the message, so we need it to be in the future epoch. So, and yeah, the members eventually can verify the content of it, and the DS won't see or disclose anything, or get to know what's going on between those. So it's a private handshake basically. And yeah, so could you please go to the second slide, the other slide?
I'm just going to add one thing here. So the idea, so there's information about just kind of like you could encrypt something for the root of the ratchet tree. Instead, we've got a public key, a public signature key, and a public encryption key for the whole group that we're going to tell other people about.
Yeah. So yeah, here are some attacks we need to prevent. The DS could be flooded with the external proposals that the DS basically doesn't know about, because it's a private message. And the current system that we have, if they want to to join, it's my idea or Ron's idea. Do you hear me, Ron?
I hear you. Yeah, go ahead.
Yeah, because I saw a message, but yeah. So we need to mitigate the application protocols for requiring privacy pass to make sure that for these users to not get to decrypt or enable the external information that was shared. And so I don't recall if you can recover for me the attack, the active attack. I don't recall it in the draft. So probably you've added it. I don't recall it.
Yeah. So this is just if I'm getting a public key, public signature key for the group, I'm going to need some way to make sure that I know if I join the group that I really did join the right group and not the group of an attacker that just sort of created a sort of an extension to the real group. So one thing that we could leverage for that would be like the authentication secret or something like the authentication secret, which we could HMAC with some random value.
Do we have another slide for it? I think
that's it.
Yeah.
Yeah, that is it. So in summary, we can make the private message handshake DSs be able to get external proposals with a similar level of privacy that they get if they were added by a member. That sounds kind of nice to me. Any comments on this? Britta?
Okay. First of all, I like the idea of having more privacy. So kudos for that. Second, my last question was actually the segue into this. It's coming. And it really boils down to what are our trade-offs here? So similar to the last time I asked, are we giving more information to the AS than we did before? Is this enabling more traceability than we had before? And that's not necessarily a done deal as far as trade-offs come with pros and cons of what is it protecting against. So if you clarify that a little bit, that what more traceability there is by either the AS or DS, or less traceability respectively, that would be great.
Yeah, so there's less traceability in that there's no leaf node revealed of the party that's sending this. And if this is implemented at the application layer by someone, you could imagine an application layer protocol where the new joiner uses OHTTP, it talks to a privacy pass, it goes and gets some kind of a token, and then it goes and spends that token to send an external proposal that's encrypted in this way, so we can go and join this group, and it's nobody outside of the group gets to see who this was. Just that it was a user that was authorized and hadn't used up their quota of messages to send.
But doesn't the AS have to have access to a group key and therefore know the group members?
So there is a public key of the group which is distributed, but the AS doesn't need to know that. The DS sees that in the advertisement of the group. It sees a public signature key for the group and a public HPK encryption key. But it doesn't ever see a private key for the group.
Does it associate that group to the membership?
So it knows that someone is encrypting to that group, but it doesn't know who that someone is. So it could count the number of times that somebody sent an external proposal and tried to join, but not who specifically tried to join.
Okay, thanks.
Rafael.
Yeah, same as Britta. It's great to have more privacy, of course. I'm not sure I fully understand the proposal, and I guess I should probably go and read the draft first, but maybe you can answer that quickly. So it sounds like you're encrypting external commits, but that's not what's happening, right? You're encrypting an external join proposal.
So it's an external, so what is described as an external join proposal, you could as well use the same mechanism for an external commit, but if it was an external commit, it would be like an external commit that where I got my group info from, for example, another one of my clients. I could do that. I don't actually think that there's a compelling use case for external commits in this case, but for the sake of explaining that the mechanism does not forbid it, I left it in the draft.
So yeah, so there's multiple levels here. One is you describe a mechanism to encrypt something to a group, and then at that level, it doesn't matter what you encrypt. But then on the layer above, you encrypt a proposal.
It has to be it has to be something you can stick in an MLS public message. So it would have to be a commit or a proposal.
Right.
And if it's a proposal, obviously it has to be an external proposal. So those are your two choices. So yeah, and that's because the structure takes a public message. That's it.
So the draft is about describing how you can encrypt to a group. Is that correct?
It's about how you can encrypt to a group, and then also about how you can publish, or how you when you send ordinary commits, how you can commit to, unfortunate use of crypto terminology and MLS terminology, how you can assert that there is a particular public key for encryption and a particular public key for signing for the group, and because that's visible to all of the members, you're going to break the group if you lie about that, if one member lies about that.
So there is a signature key that is a group
ephemeral
signature key, essentially,
an
because every
ephemeral
group
group signature
member
key. Yeah.
knows the private key, and that is potentially per epoch because it was derived from the key schedule, I assume.
Yep, exactly.
And so how do we know that it belongs to the group?
So take a look at the draft.
Okay,
But
fair enough.
it's like we're relying on the fact that an honest committer will do this. We'll put this in the AAD, this external encryption info. But when it arrives at the other members are going to notice if this doesn't match their idea of what these keys should be.
Okay, yeah, I'll read up on that. And then one final question. What was the specific threat model you alluded to earlier? Was that a malicious client attacking the DS or some other server component, or was it a client attacking other clients from the group?
So the last attack that I mentioned has to do with it's really an application level problem, but it's the discovery of this public key. So if somebody goes to discover this public key, how do they know after they've joined that they really joined the correct group and not the group of an attacker?
So after they join, but that is not really part of the protocol so far, because you can only send a proposal. So after they joined implies that there is actually a welcome, a commit, a welcome, or whatever the mechanism is, right?
Right. So I would welcome if there's some nice way that we can get a property where somebody can be sure that this really is the correct, that they discovered these keys and that they really are the correct key for a group, and not a forgery. I would love to see crypto that would make that happen. I could not come up with a way to do that.
Okay, yeah, thank you for clarifying. It sounds still very interesting, but also an aggregation of a lot of different things, different mechanisms at different levels and whatnot. So yeah, I'm looking forward to reading the draft actually and see how we can place that.
Am I doing on time?
We have 45 minutes left, and you are the final presenter.
Okay. Easy.
So I was going to say, like, are we moving on to the next?
I
Draft.
can move on, but go ahead and ask a
So
question.
my question is, there was a lot of discussion about that particular draft. There
Mm-hmm.
seems to be some interest. So please continue the discussion on lists so we can determine whether it's eligible to be adopted by the working group.
And I wanted to say something. It looks like this room is filling up. So like if you didn't sign in, please sign in. So next time we get a bigger room. Okay, this one is a very, very short, very simple draft. So right now, when you go to send a message, whether it's an application message or a proposal or a commit, you are going to create this structure called a framed content TBS. Stupid autocorrect. So this frame content TBS structure contains, for members, it contains the group context, the entire group context. We've been recently doing things with group context that makes it from, kind of getting a little bit large to kind of really pretty large. And so every time you go to send an application message, you're going to hash the full group context. That's really not necessary. The group context only changes once per epoch. So the idea here is that rather than put the group contexts in the frame content TBS, we put a hash of the group context in the frame content TBS. And then we need an extension to negotiate you using this instead of doing the normal thing. That's all there is. I think it's pretty simple. I think we should have done this ages ago. Any comments?
Who's read it? That's the problem.
Has anybody read the draft?
I think that's the problem. Oh, Raphael.
Since we have 45 minutes left,
So you read it and get back to me at the end of the.
I just want to say this is very similar actually to getting rid of some of the signatures by including hashes. So it's on the same level essentially.
Yeah, these are the kind of easy optimizations that, if we were preparing MLS 1.1, it would be really natural, but we can still do with extensions depending on how hard it is to negotiate them. All right, moving on. Okay, new content types. This one is a little bit more admittedly out there, but right now we've got application content type, proposal content type, and commit content type. We currently have two root ratchets for each potential sender. We have one for application messages and one for handshake messages. So that's proposals and commits. Now, application messages can really vary quite a bit in terms of what the application layer needs from them in terms of decryptability. So the idea here is that there are a lot of status messages and some types of ephemeral messages where we don't really need to go decrypt a bunch of old messages. So if I go on, if I went on paternity leave for, or if I went to go hike the Grand Canyon or something for 3 weeks, it's very likely that my clients could still, come back online and connect and get old messages and sync up. But I don't really need to decrypt somebody's presence update that 4 times a day they changed their I'm in a meeting, I'm not in a meeting, I'm available, I've gone home. That's irrelevant after the fact. I really only care about the most recent of those messages. And even more ephemeral, if somebody's sending me an is typing message, I could care less when I'm in the Grand Canyon. When I'm back, I could care less whether they were typing at the time that I was in the Grand Canyon. I don't care. My client doesn't care. They're not going to do anything useful with those messages. It's just a waste of power, processor, and a drain on the user interface. So we can mitigate this by having two new ratchets. We can have a status ratchet and an ephemeral ratchet. And the advantage here is that we can fast forward aggressively through generations. And we can even, if we see that there are a bunch of messages in previous epochs for one user, but there's one recent status message, I can just throw away those other messages and just take the most recent message, fast forward to that generation, and decrypt it. With ephemeral, I don't even need to look for the last one. I just throw them away unless I'm actively online, and then I decrypt it. Go for it, Raphael.
Yeah, maybe you're going to explain. Sorry, I thought you were at the end of the presentation for that part already. I'm going to withhold my question.
Go ahead. Maybe I am at the end. I don't know. Yeah, I'm at the end. Ask your question. Ask away.
Okay, so we have the forward secure exporter now, but that is not good enough because we would have to redo the secret tree, and you want to reuse the secret tree. Is that correct?
So it's just there's a figure in RFC 9420 that shows a handshake ratchet and an application ratchet. This just adds two more ratchets.
Right.
So we're not changing.
I understand, but I'm asking why. Why do you want to do it there? Is it so you can reuse a secret tree, or
so
we have the exporter otherwise?
Hmm?
We have the exporter already. You don't need to do a modification deep inside of MLS if you just want to export key material.
But I mean, we're talking about something that's at a parallel level to this, to the application ratchet.
So because you want the per sender ratchet.
Exactly.
Okay, that was my question, yeah. And then you said you can skip things.
Yeah, and it says...
So that would mean that's an entirely different kind of ratchet. Or
No, you fast forward. So there's a setting in RFC 9750, MLS architecture, in section 7. It says that you need to, implementations need to agree on the maximum number of steps that you can advance in one of these ratchets.
That's
And
correct,
so,
yeah.
And so it says in this document, it says whatever that setting is, if you were about to fast forward past that, send a new commit. So you never exceed that number.
Fast forward as a sender, you mean?
Fast forward as a receiver. So I got messages. I got 197 presence updates from you while I was in the Grand Canyon. I skipped to the last one, and I read it, and I see that you're at IETF, and I'm like, great, let's grab some lunch.
No, I mean, I understand the use case. I'm just not sure about the specifics. So you cannot skip in the current ratchet. You have to hash.
Forward.
Well, fast forward is a bit of a vague term.
Mm-hmm.
You have to actually ratchet.
But you don't have to decrypt the messages that came in before.
Sure, but ratcheting in and of itself can be expensive. That's why we have the limit. That's the only reason why we have the limit.
But it's less expensive than decrypting all of those messages, which is what you have to do now.
No. I mean, if you receive a lot of application messages, you can decide not to decrypt them.
And how do you decide until you
can still
decrypt
ratchet
them?
forward? Well, I don't know what the logic of the application is, but the application can decide to not decrypt them. and
So
still ratchet forward.
this has built-in logic that allows you to decide whether you want to decrypt them or not with the information that's available that is not encrypted. So
Okay. I just wanted to make sure we're still talking about the same ratchet.
same ratchet.
That is somewhat expensive to fast forward. It's not a zero cost thing.
But
So-
a lot cheaper than decrypting and verifying.
I'm not sure about that.
Well, you don't have to verify the signature of a
Well,
message that
okay,
you don't
but-
decrypt. And the signature is going to be way more expensive than a hash.
I agree about the signature, but just decrypting and verifying the signature are two very different things. So, I mean,
All the work that you normally do with a message, with an incoming message, compared to and you have to hash to that point in the ratchet. So all of that work reduced to just hashing, that's a lot less work. That's my point. Hopefully I didn't, hopefully I'm not saying anything now that's incorrect. So.
okay. Yeah, I mean, the risk here is that you propose something relatively specific, meaning you want to reuse the same ratchet and you want to skip decryption and verification. You could also propose a new ratchet, which is even more efficient. That's what I'm saying.
Conrad.
Yeah. So a quick question. Why, instead of introducing specifically status and ephemeral, why don't we make content type extensible? Like, why don't we make it an IANA registry? And then you can still add your two status and ephemeral kind of types.
Do you add new ratchets for each content type or not?
Yeah, we could. I mean, why not?
Because right now, we were talking about some other. When we were talking about intents. I said, well, you could create a new content type called intents, but in this case, it would reuse the handshake ratchet, right? Or
Sure.
it could.
I mean,
right? So I think that it's maybe a little bit more complicated than just saying I define a new content type. You'd need to say what the behavior of the ratchet is that corresponds to it. But yeah, we could make it IANA an IANA registered content types thing. And this document actually has that at the end. So
okay, just to maybe explain where I'm coming from. Like in the past, there's no concrete proposal right now, but in the past, I've thought about things where I thought, oh, there is something I'd like to send to the group, like, and then if you want it to be encrypted, or if you want it to be like have the authentication that you get with a public message, you have to essentially redefine a public message or a private message. And that's so annoying. Like, even if you do an extension, you just copy paste or something. So why not just make that extensible? And this would be like, I like what you're doing here, even outside of this, making it more generic. But yeah, this might be a nice opportunity to, two birds, one stone.
yeah, and to clarify, this does not change private message. It doesn't require a new message type or wire format. So, Brendan.
Hey, I wanted to say that I like this, but I would propose two changes. One is I would say that there would be just one new ratchet, which is just ephemeral. And for signaling anything more than that, I would put that at the application layer. And then on top of that, we have this one ephemeral ratchet. I would say that there should be a new kind of ratchet structure corresponding to that, like your conversation with Raphael. Yeah, like a different kind of ratchet tree structure that's more like a tree rather than just a chain. So it's more efficient to run through that really quickly. But yeah, I do like this a lot.
Thanks.
Similar to what was mentioned before, I'm not really seeing how this is much more cheaper than advancing the ratchet itself, because you don't have to verify a signature if you don't want to. But my other concern is these are unencrypted, this metadata is not encrypted as far as I can tell on the wire, otherwise you would have to decrypt that information. So you're starting to leak information that is not encrypted. And maybe for this, it's okay that there was a status message. As you go further and further, you get into this very awkward conversation of like, what am I actually encrypting and what am I leaking to an observer, because the observer knows which ratchet it was on. And that information might be all that they are after in certain cases. Like maybe I send an away status and I just want to know, when is this person not at home so I can rob their place or something. Like, I would be very careful with sending unencrypted information over the wire is I guess my main like question around this. Like, I don't like sending metadata that like everybody can see just because we can.
Yeah. To clarify, I mean, I think that this comes from a real need in terms of performance in large, particularly in large groups, or in groups that have. If you visit, you know, some Discord groups or some enterprise-oriented applications, they're going to have lots and lots and lots and lots of status messages, to the point where you're getting them, you know, the client is sending them automatically like every few minutes. Being able to know that you don't have to decrypt those, that is a significant performance improvement for clients, particularly, you know, and for battery life on mobile. And so, you know, I would be happy to have a security considerations section that says, if you're in a small group, or if you're in groups that have, you know, where timing and metadata attacks are expected to yield very useful information, don't do this.
Yeah, thanks. So that was actually a very, very good remark, because it hadn't occurred to me since it was also not on the slide. Are you proposing to reuse like private messages and then to use encrypted sender data for the generation?
I was just going to send ordinary bog standard private messages for all three ratchets.
Okay, because then we don't have that particular problem.
The content type is still visible.
Yeah, but the generation is encrypted, which is the interesting part here regarding the metadata.
So I think what Sophie the attack Sophie described is still possible if you just have a content type and the time that the message was received.
Sure, but that's a broader MLS problem, right? Like observable metadata on messages, but we wouldn't see the specific generation, nor would we see who the sender is, etc.
Correct.
But then, so maybe that's an upside, but the downside is it's going to be slow again, because you need to decrypt that. You cannot skip that. So you cannot fast forward 200 messages while you were hiking in the Grand Canyon, because you still need to decrypt the encrypted sender data.
Yeah, you have to do that part.
Okay.
But you can skip the signature. So, all right. That was a nice discussion. Thank you. All right. I don't really need to talk much about any of these. We've discussed this before. There are three specific parts of MLS extensions: the safe extensions framework, the content negotiation, and self-remove proposals that are currently referenced in MIMI documents. There's also ratchet tree options and semi-private message. Last time we talked about this in Madrid, I think there was some interest in ratchet tree options. There were multiple implementations. There were not multiple implementations of semi-private message. Actually, I don't think there is maybe not even a single implementation yet. But the rest of the stuff, there are people who are implementing. It'd be great if we could adopt ratchet tree options. Just saying.
Who's read it?
Who's read ratchet tree options?
Who's read ratchet
I know,
tree options?
I see people in the room that I know have read it. So either you're asleep. Okay. Yeah, I think, I know most of us has read it. Britta, have you read this? Ratchet tree options? I think there are some people.
I confess I have not.
Okay,
Sorry.
bummer. It's worth a try. Okay. But yes, ratchet tree options, it just has ways to convey the ratchet tree and to convey either the full group info or the partial group info. Originally written up by Conrad and Raphael for the partial group info. So, okay, yeah. All right, my last slide. Okay, we've got, how many extensions do we think we have in MLS right now?
A ton.
Anyone want to guess? Just lower. Not far off.
I'm looking at your
So I counted 24. I wondered, as a thought experiment, how many of these extensions work with the other extensions? So, I didn't, this might be 75% correct. But I think this should be a good indicator about the potential problems that we have. So when I send messages about, could we do that without changing this wire format, without using a wire format here? One of the reasons is that if I am doing something that needs a new wire format to send a commit, like split commits, and another one that needs a new wire format for a commit, those are not going to work together. And it's going to be almost impossible to make them work together. So the things that are red, those were places where I was like, I think that just plain won't work. Like the way that it's spec'd, there you can't make that work at all. The ones that are yellow, those are places where you could take the two things and you'd probably have to have, if neither, if A, if B, if both, and you'd have to have separate logic for each of those four cases. Doable, but not necessarily the best thing to have lying around. Plenty of question marks where I was like, not really sure. But this was just to raise awareness of this idea that when we're defining extensions, we want to think about, are we making it difficult to implement other extensions? Are we making it difficult for an implementation that might want to support two different environments, like a stack that works in a private message handshake environment and a public message handshake environment, that they have to have a lot of complicated knobs or compilation options and a lot of extra test cases. So I'm just going to leave that as my last thought. And unless you actually have a question, I'm going to go ahead and sit down and have a drink of water.
You do that. I think that looks really interesting. Thanks for doing that. I'm wondering what we can do with that now. And so maybe regarding the question marks, but also regarding the yellow and the red squares, maybe it would be a good exercise if the authors of a specific draft looked at the compatibility of their stuff with other drafts specifically. And that's a two-way process. And then we could compare, what the authors of draft A say with regards to compatibility with draft B and vice versa. What authors of draft B say regarding compatibility with draft A. Maybe we can, we can raise this confidence level of 75% that you just expressed to something slightly higher.
Yeah, and I want to point out that there are actually some big chunks of all green in here, right? So there are a bunch of things that were defined in the MLS extensions draft that are individual extensions, and they appear to all work with each other just fine. They don't interfere. They just should just kind of work. So, hey, like we can celebrate that at least.
Okay, great. That brings us to the end of our agenda. Thank you, Tim. Did you want to say something?
Sorry, I forgot to click the button.
It's cool.
This table, Tim Gagan, ISRG. This table that you worked up, did you do so just by like reading all these drafts and then deciding? Okay, so you didn't build like a test harness that runs all these things.
So I thought we were going to go to that exact route. So that's where I was hoping we were going to go, or somebody was going to say AI and we were all going to get excited. But this could lead to an interoperability matrix. There are a couple of working groups that do have test harnesses that they can automate and set stuff up. And that might be something that would be pretty cool if we could pull off. Tim, you're in again. No, you're out. Okay.
Just for the record.
Yeah, appreciate you taking notes for us. The chair's picked up some action items. We're going to do a working group adoption call, I think, for virtual clients. We want to talk to the distributed and decentralized draft authors, figure out what we're going to do there. And I guess one other thing, this working group is rather quiet on the mailing list. When we send out an email to figure out whether we want adoption calls or working group last calls, please respond. Please be clear in your emails, because it helps us be able to judge consensus and then be able to point at it for our area director who goes, there were 3 messages, what gives? So thank you very much. Appreciate it. Have a nice day. So can I talk to you for like 5 minutes after this? Away from the outside right now. We have the microphone. Hey Mark, are you guys around? All right, cool. We'll be looking for you, all right?